Okay. So the two things I want people to know, which is the difference between the natural log of x versus e to the x. Okay, so a natural log of x, usually denoted as ln, is called natural log of x, versus e to the x. Huh? Okay, so so in terms of basic understanding, is you have to understand two graphs. So I'm gonna erase this. I'm gonna say e to the x. E to the x graph is probably most foundational things anyone should understand. And too bad I don't have enough time to explain about e. But e is definitely one of the most beautiful number in the world. I think in many sense, e is actually more important than pi. In many application goes. So it's called Euler's number, and it's using for natural growth and things like that, nature. But this is a e to the x graph. There is an asymptote on this side. You have to know this graph very, 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 very deeply. Also, another question that you need to know is, another graph you need to know is there's an asymptote here because they are inverse of natural log. So it looks like there was a symmetry here. And that's y equal to x. Okay. So since they are inverse to each other, so it must mean that something's super important. Natural log and e to the x. Well, what is e? E is roughly equal to 2.718 something, 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 about approximation. A very good student can probably know like 10 digits. Fortunately, I wasn't a very good student. So I just says 2.798. That's called Euler's number. And I'll show you its definition of Euler number. We're going to come back to this. Is limit as x approach infinity 1 plus 1 over x to the x power. That is a definition of E. Now, that's a calculus definitions. And also, it should tell you that in Algebra 2. It should teach you and things like that, nature. But I don't have time to go through it because we have an AP exam to prepare. But this is probably one of the most beautiful concepts there is limit as x approach infinity of 1 plus 1 over x to the x power. If x approaches infinity, then that's equal to e. Very, very cool concept. Very, very cool. Now we're going to talk about strictly on a red graph. I'm going to use a red color so that way you can see. As a limit, x approach negative infinity of e to the x. What am I going to get? What am I going to get? No. To the negative infinity. If I x approaching negative infinity, what am I going to get? 0. Good. So you fix that because we go in this direction. And then eventually it's going to plateau to the y value of 0. But it's going to get infinite close because that's a horizontal asymptote. So the red line, the red dotted line is horizontal asymptote. So that's equal to 0. That's something that you need to know. Also limit x approach to infinity of e to the x. Now this one is going to be infinity because it goes exponential larger. and it's so large that you can't really define. So we're going to call it infinity. And another thing is e to the 0 is what? What's e to the 0? Anything to the power is 1. A lot of people on the last test, they did 16 to the 0 power and they put down 0. And that's not correct because anything to the 0 power is 1. Any questions here? Okay. Now we're going to talk about a blue graph. Blue graph is natural log value. So if I have limit x approach infinity on natural log of x, that's just going to go to infinity. The graph is still going to go up. And if I go far enough, it's still going to keep on increasing. Nonetheless, natural log is going to be very, very slow speed. But however, it's still going to go up to infinite. Now, the thing is like kind of different from the prior one is x approach to 0 from the left side. If I approach 0 from the left side, that's equal to negative infinity. Because it's going to go straight down. Now, since natural log and e are inverse to each other, you must need to know is this. Like super important, right? Natural log of e is equal to 1. They are inverse to each other. So natural log of e is going to be equal to 1. They cancel out exactly. Natural log e to the x, that's going to give you x. Because natural log of e cancel out. But x is going to place in the front due to another property. Also natural log of 1. Does anybody know what's natural log of 1? Anyone? You can look at the graph. You should be able to tell me what's natural log. Huh? It's 0. Like this is super important that you have to understand that completely. Everything else is like super important too. It just like the time we're using it's like depends on depends on situations. But yeah, but that's a basic understanding. So let's talk about what's on ACT. ACT has some simple logarithms. Logarithm you can have different base. So log format is going to be log of b. This represents base. So most of the time, like something called common log. Common log is log base of 10. And they also don't write it base of 10. They just write down log. That's it. This log is used for calculate pH. How many of you guys taken AP Chem or have taken AP Chem in the past? AP Chem in the past or currently? Currently, okay, good. Anybody else taking AP Chem? No? Okay. So if you guys remember, the way to calculate pH is actually negative log of hydrogen ion. Do you know this rule? You should know this because depending on what your hydrogen ion is. Let's just say if you have a 0. You have a you have 0.01 molar. So if you have 0.01 molar of hydrogen chloric acid, the pH is equal to like a dog because the HCl is 100% dissociations. If it's 100% dissociation, that means they're gonna dissociate completely. For those of you guys never took chemistry before, hydrochloric acid is a strong acid. Do you guys remember that? No? Dev? Are you taking AP chemistry next year?
Probably not, but like we did this in AP Bio.
Okay, good. So log of hydrogen chloride acid So it'll be, let's say 0.01 molar. Is there 100% dissociation? Those of you take a lower, take chemistry. It's a hydrogen hydrogen fluoric acid is a strong acid or strong base? A strong acid or weak acid? It's a weak acid. It's not even a strong base. But well, it has like one of the strongest electronegativities, which is they attract, so they don't dissociate easily. So that's probably one of the things. But hydrochloride, hydrobromide, I don't know. There's a lot of sulfuric acids. They are all like a very, very strong acids. Sulfuric is really strong, stronger than hydrochloride. So that's gonna be negative log of 10 to the negative 2. So log the base 10 and 10, they'll cancel out, will be negative 2. So that's gonna be pH of 2. So pH of 2 is like a stomach acid. Stomach acid is probably 1 point something. It's actually hydrogen chloride. And there's a reason why Mr. Patel, my best friend in the Cyprus, it's really like much like Mr. Davis. He knows a lot of stuff. Like he will always ask students, like, do you know why hydrochloride is a strong acid but doesn't burn through your stomach? Do you guys know why? Sarah? No. Cage?
We have a mucosal lining in our stomach that's under dissolved.
What is it?
We have a mucosal lining in our stomach that's under dissolved.
So yeah, that's something that you probably need to understand if you're in biomedicals, right? So yeah, a lot of those things are very, very important if you want to become a doctor, and that's very, very important. So pH of this case is 2. The reason why it's 2 is because of this log 10 of 10. They're going to cancel out. And that's going to be negative 2. Negative 2 times negative is going to be 2. That's a pH of 2. Some regular situation, let's say, if you have 2 to the third power is equal to 8. This is called exponential form. And you can convert to logarithm form. How do you convert to log form? Do you guys know? If I have a 2 to the third power is equal to 8, it's a statement, right? It's true. Can I convert to log format? That still hold true. How? Yes.
Did you log base 2 3?
No. Okay, so a good thing that we're gonna teach you here. So this is called a base. This is an exponent. You always start with the base. So I'm gonna draw in reds to help you. So it's gonna draw a heart, a sideways heart. That's equal to log base 2 of 8 is equal to 3. And you can also convert back. 2 to the third power is equal to 8. You always start with the base. You draw a sideways heart. So 2 to the power per power is equal to 8. You don't understand how many ACT questions you can take care of. I think you can take care of most of the log questions. Just basically understand this concept. Because it could be like just as easy as log 3x plus 1. Like this is equal to 81. You can basically solve this. I'm sorry, this one is bad. Let's say 4. like this. So all you gotta do is change the log form. How do I change the log form? 3 to the 4 is equal to x plus 1. So 81 equal to x plus 1. X must be 80. And that's how you solve a logarithm problem. And that's if log base of 3. Log base of 4 is different, log base of 5 is different, log base of 10 is different. But a common log is going to be log base of 10. Unless they otherwise notify. So like square root, usually if you have radical, that just means square root. It didn't imply that's 2 there, but it's just always 2 is always there. Now, if I write down a 3 on the indexes, then that's going to be the 3rd root, that'll be 4th root, that'll be 10th root, that'll be 11th root. You can have as high a root as possible. It really depends. So this is the 3rd, log base of 3. Now you're going to say, well, what is natural log? Natural log is log base of e. So it's not really as large, all right? It's going to be log base of e. If log base of e is equal to natural log, sometimes, they say, what's natural log? It's log base of e. E is 2.718, so it's equal to the special number. It's called Euler's number. Those of you guys don't know, if I write down this should be Euler's number. Very, very important number in the world. It's also in the movie Hidden Figure. The black Katherine Johnson is one of the black astrophysicists, and she's actually doing the one. She's actually using Euler's approximation, which is we're going to talk about in calculus too, is Euler approximation, and use Euler's approximation figure out how to project the rocket to the correct orbits. Very, very, very hard thing to do. But she's the one that pulled from the old calculus textbook, and she able to get that accomplished, where other people had no idea how to do it. And she happened to be black, so, and even that she's able to check the IBM calculator. IBM back then, this first computer NASA used to calculate stuff, and she able to find a mistake of calculation from the IBM computer. That computer or TI-84 just as big as this room. So one TI-84 just is going to be big as this room or multiple room. Back then the technology is, now you can compact into a graphing calculator. It can be just as functional as back then. Very, very powerful stuff. So log base of e. Okay, any questions? So you can convert it to 2 different forms. So I can ask a question like say this: log 2 of x equal to 3. So what will be x equal to? Yes, who says 8? Good job. Because 2 to the 3rd power is equal to 8. So equal to x. X is equal to 8. So that's how you have to be able to solve the problem. Now we're going to talk about some basic things for logarithm. So remember, in this case, the property natural log can also using log. It's going to be the same rule apply. Now, same property. So same property. And we're going to talk about property. Why is this property important? Is natural log of x plus natural log of y is equal to natural log of x times y. This is a first property. If 2 natural log adding together is equal to the things multiply each other. And I don't have time enough to prove you that's true, but that's actually pretty cool. Natural log of x minus natural log of y due to understanding by associations, what do you think is going to be? Dividing. Very intuitive. Natural log of y to the x power is going to be natural log, oops, my bad. This is x like this. Natural log of x to the y power like this. And last also very important is how do you convert log from base b to a? Is there any way I can convert log to natural log? There's something called changing base equation. So it's going to be natural log of a over natural log of b. B is on the bottom, base is on the bottom. Always understand that smaller things on the bottom here and bigger things on the top. So it'll be natural log of a over natural log of b. So everything in it can be, again, you can do everything as a logarithm rules. They apply to both. What time we get out of here? Okay, good. So we have enough time. So they are the same property. Natural log of x plus natural log of y equal to natural log of x times y. Natural log of x minus natural log of y equal to natural log of x over y. Y natural log of x equal to natural log of x to the y power. And log a, log base b to the a is equal to natural log of a over b. And this is due to a exponential form that's coming from here. Remember a to the m times a to the n is equal to a to the m plus n. And this is a to the m over n power is equal to a to the m over n. Oops, not m over n. M minus n. And that's the reason why they are that way. And the a to the m to the n power is equal to a to the m times n. And that's the reason why you got this third rule. So this is an exponential rule. And that's what create that rule there. So exponential rule is very similar to logarithm rules, except they are similar in their own way. Questions here? No? Maybe? Yes? It's good? Okay. With that being said, this is super important. Now, anything this direction is called a condensations. Why is condensation? It is actually take 2 log, condensed to 1 log. So it's condensation. Math actually work both ways. This is actually more popular in calculus, is expansion. Because so much easier to deal with expansion of a logarithm, and then you can take a derivative or integral, much more efficient if you can do expansions. We're going to practice condensation first, and then we're going to do expansion. So what happens if you have natural log of x2 plus natural log of y? Can I write in one natural log? That's called condensation. How do I condense this? To 1 log with no coefficient in the front. A natural log and no coefficient in the front. Is it possible? Yes.
It's ln x squared y.
Yep, perfect. First, you use the third rule. So it'll be ln of x squared plus ln of y. And since they are adding, so it's natural log of x squared y. Does that make sense? So this is called a condensations. Can I do an expansion? Can I have this? Can I expand them? As many logarithm is possible, huh? Z to the square. If I write a line in the middle, it's going to be Z. Y to the third, yes. And X to the square root. Now, this is something you got to be able to do in terms of calculus because you have to do this. If I would ask you to take a derivative, you expand them. And you take a derivative, it's so much easier. Yes. Huh? Sure. What do you think the answer is? How many people agree with this and how many people disagree with this? Minus what? Ethan, did you agree or disagree?
That I was thinking was like, would it be like y plus z? Because
Ah.
like those two are 5 not being divided.
So Ethan says it should be -3 natural log of y plus 2 ln of z. Is anybody thinking the same track as Ethan? Huh? Yeah. Okay, 2 people. Anybody else? Yeah, plus 2 ln z. You think the same way?
Yeah, because like normally it'd be like parentheses because like the denominator, but once you like FOIL it out, the negative will apply to both.
Katie, what'd you say? Katie, I cannot see you. I cannot hear you. Yeah.
I think it's kind of like that. I don't know exactly how they FOIL, if you're supposed to FOIL out the negative sign or not.
Okay. It turns out Sarah Z is right. And Katie is also right. Because you're dividing by y to the cube as well as you're dividing by z to the square. So when you divide, it's always subtracting. Or some people can think of this. Let's break it up slowly. So we yn ln of x minus ln of y to the third z to the square. And since that, it's going to be 1/2 ln of x minus this one is going to be adding. So it'll be ln y to the 3. And 3 is going to be in the front plus ln of z square. But if we distribute it, it's going to be still minus 3 ln of y minus 2 ln of z. Does that make sense? Very, very crucial for you guys to understand. Good job, Sarah Z.
Can you like write
What?
something for my working team so he knows that I was here,
What do you mean to write?
like a pass or something? Or you can write on that.
Oh, no one cares.
But he cares. He's like that.
Really?
Yeah.
Then why don't you tell me earlier? I won't let you stay here. Are you doing good in that class?
Yeah. Is there like a number for ln or log?
ln is it's like a square root.
Oh,
It's a operations.
okay.
ln of something is an operation of something.
What about log?
Same thing.
Same thing.
There's no number for it. So like square root. Square root is a machine that just take the number which 2 numbers multiplied together is going to be that. Logarithm is going to be the same way, except it's back. What's his name?
Benedict.
Mr. Benedict,
Benedict.
BENDT.
E-D-I.
To Mr. Benedict else. Talking to Sergio about situations and to stay for lectures. You guys cannot be there anymore.
Yeah.
And also
Oh, I
homework.
couldn't. The reason why I was here late is because my mom, she's like yelling and stuff.
Why is she yelling at you?
No, it was my sister. She got mad. I couldn't come.
Dude, not because of that. You are always there. You and Will is like
Well,
twinsies.
no, not always.
It's pretty always. Because
And it's mostly because of that.
yeah, you're always late. But yeah, you guys need to straight up your act. Hey. Not much. No, you're not.
Wait, didn't they take a test like Friday?
Yeah, but I take a second part of the test. Because they didn't have time to finish it.
Yeah, so Max couldn't walk today because he